Picture a memory from your earliest days of learning about the cosmos. Recall the glossy pages of an astronomy textbook resting heavily on a desk or a large poster pinned to the wall of a dimly lit classroom. On that page, or that poster, you saw a magnificent spiral of light against a sea of pure black. It looked like a brilliant cosmic pinwheel, majestic and perfectly contained. There were neat little arrows pointing from one edge of the glowing disk to the exact opposite side, and between those arrows sat a number. 100,000 light years. That was the absolute, unquestionable measurement. It was etched into our collective understanding of the universe. It was the scale of our home. We were taught this number as a fundamental truth of nature, as reliable as the ground beneath our feet. We built our entire cosmological map around it. For 70 years, every documentary you ever watched, every scientific paper published, every simulation rendered on a supercomputer relied on that specific measurement. We believed we lived in a very specific, well-defined volume of space. We were wrong. We were profoundly, spectacularly wrong. The Milky Way is not 100,000 light years across. It is not even close to that size. It is at least twice that scale, and possibly much larger still. We have been living inside a galactic structure double the size we imagined, and we missed it completely. This is not a slight miscalculation. This is not a rounding error or a minor adjustment of a few percentage points due to better instruments. This is a massive structural rewriting of reality. Imagine waking up one morning, walking out the front door of your house, and realizing that the building you have lived in your entire life actually extends for miles in every direction, hidden behind a veil you simply never noticed. Imagine finding out that your living room is just an antechamber to a sprawling, monolithic palace that has been sitting there in the dark, quietly surrounding you all along. That is precisely what has happened to modern astronomy. To understand how brilliant minds could make such a colossal mistake, you have to understand the unique and frustrating geometry of our situation. We are not external observers looking down at our galaxy from some privileged, omniscient vantage point. We are deeply embedded inside it. We are trapped roughly 26,000 light years away from the chaotic galactic center, floating in a minor offshoot called the Orion Spur, which branches off from one of the main spiral arms. We are drowning in the very thing we are trying to measure. Imagine being blindfolded and dropped into the absolute center of a dense ancient forest shrouded in thick fog. You are told to draw a perfectly accurate map of the forest boundaries, but you cannot remove the blindfold, and you cannot walk to the edge. You can only stand exactly where you are, listening to the rustle of leaves, feeling the temperature of the air, and trying to guess where the trees finally give way to open plains. That is the predicament of the human race. We live on a tiny sphere of rock, orbiting an entirely average, unremarkable yellow dwarf star, drowning in a dense fog of interstellar dust, glowing gas, and the blinding radiation of billions of neighboring suns. For decades, the method used to measure the galaxy was remarkably simple and deeply flawed. Astronomers looked up into the night sky through the most powerful optical telescopes they could build, and they tracked the brightest objects they could see. They mapped the blazing blue giants, the pulsing variable stars, the massive globular clusters that hover around the galactic core like ancient swarms of fireflies. They plotted these points of light on a three-dimensional grid, building a map of our surroundings piece by piece, observation by observation. And as they looked further and further outward, away from the dense, glowing heart of the Milky Way, they noticed something that seemed perfectly logical. The stars began to thin out. The brilliant clouds of hydrogen gas grew sparse. The radiant spiral arms dissolved into isolated, scattered pinpricks of light. Eventually, they reached a distance where the visible stars seemed to stop altogether, fading into the absolute blackness of deep space. They looked at that fading light, drew a line in the darkness, and declared that to be the edge. They assumed that the galaxy was shaped like a dinner plate, flat and distinct, with a clear boundary where the porcelain ends and the empty table begins. When the bright stars ended, they assumed the galaxy ended. It was a perfectly reasonable assumption based on the evidence they could perceive, but it was an assumption built entirely on the illusion of light, The universe, however, does not care about what we can or cannot see. The universe is not obligated to be visible. The fatal flaw in our measurements was the arrogant belief that light equals mass, and that darkness equals emptiness. We mapped the bright, glowing skeleton of the Milky Way and completely ignored the invisible flesh and muscle that binds the entire structure together. The stars we can see with our eyes and our optical telescopes make up a heartbreakingly small fraction of what is actually out there. The vast majority of our galaxy does not emit light. It does not reflect light. It does not interact with electromagnetic radiation in any way that our traditional instruments could detect. When you step outside on a clear, moonless night, far away from the blinding glare of city lights, you might be lucky enough to see the Milky Way arching across the sky. It looks like a ghostly, glowing river of spilled milk, a serene and permanent fixture of the heavens. What you are actually looking at is merely the dense, inner disk of our galaxy, viewed edge-on from our position inside it. You are seeing the glowing dust lanes and the combined light of billions of stars packed tightly together. But you are missing the ghost. You are missing the colossal, spherical halo of invisible material that envelops that glowing disk, stretching out into the void for hundreds of thousands of light years. This realization did not happen overnight. It was not a single dramatic moment of discovery where someone looked through a telescope and suddenly saw a hidden wall of stars. It was a slow, creeping realization born from anomalies, from mathematical models that refused to balance, and from movements in the deep dark that made absolutely no sense. Decades ago, scientists began measuring the orbital speeds of stars moving near what we thought was the absolute edge of the galaxy. According to the laws of physics formulated by Isaac Newton and confirmed over centuries of observation, objects orbiting farther away from a center of mass should move slower than objects orbiting closer in. This is why Mercury races around the Sun in a matter of days, while Neptune takes more than a century and a half to complete a single lonely orbit. Gravity weakens with distance. Therefore, orbital speed must decrease with distance to maintain balance. If the Milky Way ended where the visible stars ended, then those stars at the very edge should have been drifting along at relatively leisurely speeds, feeling only the weak gravitational pull of the distant galactic core. But when astronomers finally developed the technology to measure their velocities accurately, the data came back completely broken. The stars at the edge were not slowing down. They were tearing through space at impossible velocities. They were moving so fast that the gravity of the visible galaxy could not possibly hold them. According to everything we knew about physics, those stars should have ripped themselves free from the Milky Way long ago, flying off into the vast, empty oceans of intergalactic space like sparks shooting from a grinding wheel. But they did not fly away. They stayed. They remained locked in orbit, circling a galactic center that seemingly did not have the mass to control them. There was only one terrifying, awe-inspiring explanation. Something else was pulling on them. Something massive, something invisible, and something extending far beyond the fading light of the outer spiral arms. We were trying to understand the ocean by only looking at the white caps on the waves, completely ignorant of the crushing, fathomless depths flowing beneath the surface. We were forced to confront the existence of an invisible scaffolding, a dark architecture that dwarfs the glowing spiral we call home. The true edge of the Milky Way was not defined by where the light died, but by where the gravity finally surrendered its grip. And as we deployed newer, infinitely more sensitive instruments into the cold vacuum of space, tools designed to detect the faint whispers of infrared heat and the subtle warping of space-time itself, the true scale of that gravitational grip began to reveal itself. The boundary was pushed outward. First, to 120,000 light years, then to 150,000, then past 200,000 light years and beyond. The numbers kept climbing, expanding into the void, rewriting the cosmic map and forcing us to reconsider our place in the dark. We are not floating in a medium-sized, neatly contained spiral. We are embedded in a gargantuan, sprawling behemoth, an empire of darkness whose true borders we are only just beginning to comprehend. The light you see when you look up at the night sky is nothing more than a minor distraction. The real galaxy is the blackness between the stars. Allow yourself to drift into that blackness now, into the vast, uncharted territories of our newly discovered home, where the old maps have burned away, and the true scale of the cosmos is waiting in the quiet dark. When you look up into the night sky, you are conditioned to look exclusively at the light. Human eyes evolved under the brilliant, unyielding glare of a yellow star, teaching our brains over millions of years to seek out illumination, to trust what glows, and to ignore the shadows. We are biological creatures wired to perceive the universe as a collection of bright objects scattered across an empty, passive canvas of black. But that blackness is not an empty canvas. It is not a void waiting to be filled. The blackness is the structure itself. The light is merely an illusion of substance, a cosmic afterthought, a thin layer of bioluminescence floating on the surface of an unfathomably deep ocean. We have spent our entire history trying to understand the architecture of our galaxy by studying the stars. But measuring the Milky Way by counting its stars is like trying to comprehend the sheer, crushing mass of an iceberg by only looking at the snow resting gently on its peak. Imagine for a moment standing in a desert at midnight, staring at a colossal modern skyscraper miles away in the distance. The framework of this building is painted completely black, blending seamlessly into the darkness of the night sky. All you can see are the illuminated windows of the offices where people are still working. Some windows are clustered tightly together in bright, glowing blocks, while others are scattered, solitary points of light near the very top. If you were asked to describe the shape and size of that building based only on what you could see, you would draw a fragmented, floating, jagged shape. You would assume the building ends where the highest glowing window sits. You would have absolutely no idea about the massive steel girders, the concrete foundation plunged deep into the earth, the sheer weight of the unlit floors, and the towering spire that extends hundreds of feet above that final, lonely light. You would be blind to the true scale of the structure because you were only looking at the light. That is our galaxy. The stars, the glowing nebulae, the radiant clouds of interstellar dust, they are just the lit windows. They are the decorative trim on a monolithic structure made almost entirely of something we cannot see, cannot touch, and cannot directly detect. Astronomers call it dark matter, a term that sounds almost mystical, but it is not a theory or a placeholder for our ignorance. It is a physical, measurable, overwhelming reality. It is the invisible scaffolding of the cosmos. Without it, the glowing disk of the Milky Way would not exist. Without it, the stars at the outer edges, moving at those impossible breakneck speeds, would have instantly flown apart, scattering into the intergalactic wind like dandelion seeds in a hurricane. We used to think of the Milky Way as a flat, spinning disk, like a vinyl record slowly rotating in the dark. But the discovery of the dark matter halo shatters that image entirely. We do not live in a flat disk. We live buried deep inside the core of a colossal, invisible sphere. The dark matter forms a massive, diffuse cocoon that completely envelops the visible galaxy. It surrounds us on all sides, above the galactic plane, below it, and extending outward into the void for distances that break human intuition. But the visible disk of the Milky Way is merely a thin, glowing wafer suspended perfectly in the center of this gargantuan invisible sphere. To understand the sheer scale of this dark matter halo, you have to try to wrap your mind around the concept of its weight. The old estimates suggested our galaxy contained perhaps 1.5 trillion times the mass of our Sun. Even that number is staggeringly difficult to visualize. Our Sun weighs approximately 2 nonillion kilograms. That is a 2 followed by 30 zeros. It is a mass so profound that its gravity easily commands the orbit of Jupiter, a gas giant massive enough to swallow 1,000 Earths, sitting hundreds of millions of miles away. The Sun contains 99.8% of all the mass in our entire solar system. Everything else, every planet, every moon, Every asteroid, every comet, every mountain on Earth, and every drop of water in our oceans amounts to little more than rounding dust compared to the sheer bulk of our star. Now, take that incomprehensible weight of a single sun and multiply it by 4 trillion. That is the revised mass of the Milky Way, 4 trillion solar masses of gravitational authority. And here is the deeply humbling truth of that measurement. The overwhelming majority of that weight, perhaps as much as 90% of it, is not made of stars. It is not made of planets or black holes or dead, cooling white dwarfs or drifting clouds of hydrogen gas. 90% of the Milky Way is made of dark matter, the material that makes up your body, the screen you might be looking at, the chair you are sitting on, the moon outside your window, and the billions of blazing stars in the sky. All of it, combined, is the extreme minority of the universe. We call it normal matter, or baryonic matter, because it is normal to us. But on a cosmic scale, we are the anomaly. We are the rare, bizarre exception. Dark matter is the default state of the universe. Scientists could not simply take a photograph of this dark matter to prove it was there. They had to weigh the ghost. They had to map the invisible by watching how it manipulated the light of things far beyond it. They used a technique born from the mind of Albert Einstein, a phenomenon known as gravitational lensing. According to general relativity, massive objects do not simply pull on other objects. They literally warp and bend the fabric of space and time around them. But imagine placing a heavy bowling ball in the center of a stretched trampoline. The surface of the trampoline sags, creating a deep depression. If you were to roll a marble in a straight line across that trampoline, its path would curve downward as it passed near the heavy ball. The dark matter halo of the Milky Way is that bowling ball, and space itself is the trampoline. When light from a remarkably distant galaxy, a galaxy billions of light years away, sitting far beyond the edges of our own, travels toward Earth, those ancient photons must pass through the outer regions of our galaxy to reach our telescopes. As that light enters the dark matter halo, it encounters warped space. The immense 4 trillion solar mass gravity of the invisible cocoon bends the path of the light, acting like an unimaginably large, just slightly distorted magnifying glass. By carefully observing these distant background galaxies and measuring exactly how their light has been smeared, stretched, and distorted by the time it reaches us, astronomers were able to reverse engineer the shape and mass of the invisible lens. They mapped the dark matter not by seeing it, but by reading the fingerprints it left on the light of others. The results of those gravitational lensing surveys were shocking. The invisible lens did not stop where the stars stopped. It kept going. The warp in space-time extended outward, further and further into what we previously thought was completely empty intergalactic space. The dark matter halo stretches so incredibly far that it redefines the very concept of our cosmic neighborhood. It reaches out for hundreds of thousands of light years, a silent, unseen sovereign claiming territory in the deep dark. And this dark matter is not just out there, hovering at the edge of the galaxy. It is here. It is everywhere. You are submerged in it right now. Because dark matter does not interact with electromagnetic forces, it does not reflect light. But more importantly, it does not interact with the normal matter of our world in any physical way. Normal matter feels solid because the electron clouds surrounding atoms repel each other. When you press your hand against a wall, your hand does not pass through the wall because the electrons in your skin are magnetically repelling the electrons in the plaster. But dark matter particles have no electric charge. They do not have electrons. They are completely oblivious to the electromagnetic force that gives our world its physical solidity. As you lie there, breathing slowly, finding a quiet rhythm in the dark, the Earth is hurtling through the Milky Way's dark matter halo at hundreds of miles per second. As our planet plows through this invisible ocean, a continuous phantom rain of dark matter particles is streaming through the atmosphere, plunging into the crust of the Earth and passing completely through the solid iron core of the planet as if it were nothing but empty space. Trillions of these invisible particles are passing through your body, through your chest, through your hands, right at this very second. They glide cleanly through the empty spaces between the atoms of your cells without touching a single thing, leaving no trace, making no sound, causing no ripple. You are a ghost to them, and they are a ghost to you. We share the exact same physical space, existing layered on top of one another, completely isolated by the fundamental laws of particle physics. It is a deeply strange thought, realizing that you are continuously permeated by an alien mass that outweighs the visible universe 10 to 1. But there is also a profound, quiet comfort in it. We often look up at the night sky and feel small, isolated, and fragile, floating on a tiny speck of dust in a hostile, empty void. But the void is not empty, and we are not unanchored. The dark matter is the great cosmic stabilizer. It is the silent, steady hand holding the galaxy together. If this invisible halo were to suddenly vanish, the delicate gravitational balance of the Milky Way would be destroyed instantly. The sun, along with all the other billions of stars in the spiral arms, would be flung outward into the freezing, boundless abyss of deep space, destined to freeze and die in absolute isolation. The dark matter is the cage, but it is a protective cage. It is the heavy, invisible blanket that wraps around our glowing disk, keeping the heat in, keeping the stars bound to their orbits, allowing gas clouds to gently compress and ignite into new suns, allowing planets to form, and allowing oceans to pool on the surface of rocky worlds. Without the dark matter halo, the long, slow, stable billions of years of evolution required to produce a mind capable of wondering about the universe would never have been possible. The darkness is not the enemy of life. It is the silent, essential architect of it. So when we talk about the size of the Milky Way doubling, we are not talking about stars migrating outward. We are talking about humanity finally opening its eyes to the invisible architecture that has always been there. We are mapping the edges of a shadow, and as astronomers push their instruments to the absolute limits of human engineering, staring deep into the periphery of this dark cocoon, they have begun to find things trapped in the outer layers. They have found the remnants of violence, the shattered, glowing debris of ancient galactic collisions, drifting in the extreme outer limits of the dark matter halo. These are the ghosts of the edge, orbiting so far away that their light takes hundreds of millennia just to cross the galaxy. The boundary of our home is marked by rivers of dead stars, silently circling in the dark, and they are waiting to tell us exactly how far the invisible scaffolding truly reaches. The universe is violent. We prefer to think of it as a clockwork mechanism, a silent, ticking orrery where planets orbit stars and stars orbit galaxies in perfect, eternal circles. It comforts us to imagine a cosmos of order. But the history of the Milky Way is not a story of peaceful rotation. It is a history of consumption. Our galaxy is a cannibal. It did not start as the majestic, four-armed spiral we see today. It grew to its colossal size by hunting, trapping, and devouring its smaller neighbors. For billions of years, the Milky Way has been a gravitational predator, pulling dwarf galaxies into its maw, ripping them apart, and assimilating their stars into its own body. This is how galaxies grow. The large eat the small, the massive inherit the void. And the evidence of these ancient feasts is still visible tonight, painted across the sky in faint, ghostly rivers of light that we call stellar streams. These streams are the forensic evidence of galactic crimes committed eons ago. They are the shattered remains of dwarf galaxies that wandered too close to the event horizon of our dark matter halo. When a small galaxy falls toward the Milky Way, it does not simply crash like a meteor hitting the Earth. The interaction is far more elegant and far more cruel. As the dwarf galaxy approaches, the Milky Way's gravity begins to pull on it, but gravity acts differently across distance. The side of the dwarf galaxy facing us feels a much stronger pull than the side facing away. This difference in gravitational force creates a tidal effect, similar to how the moon pulls on Earth's oceans, but on a scale that defies imagination. The dwarf galaxy is stretched. It is pulled taut like a piece of taffy. Its structural integrity fails. The stars that were once bound together in a tight spherical cluster are dragged loose, one by one, stripped away from their home. They are pulled into long, thin filaments, trailing behind and ahead of the dying galaxy like unraveling threads of a sweater. Over hundreds of millions of years, the core of the dwarf galaxy is completely dissolved, leaving behind nothing but a winding ribbon of stars wrapping around the Milky Way. These are the rivers of the dead. They orbit in the cold, outer darkness, preserving the memory of a galaxy that no longer exists. For decades, these stellar streams were dismissed as curiosities, faint anomalies in the data that were too dim to map and too scattered to understand. They were the background noise of astronomy. But as we began to realize that the Milky Way was hiding its true size, these streams transformed from curiosities into the most valuable tools we possess. They became our rulers. They became the only honest way to measure the invisible. You cannot map the edge of the dark matter halo with light, because it has none. You cannot map it with gas, because the gas is too diffuse. But you can map it with gravity. Every single star in a stellar stream is moving along a path dictated entirely by the mass of the Milky Way. If our galaxy were small, with a weak gravitational pull, these streams would drift loosely, their orbits wide and wandering, perhaps even escaping into intergalactic space. But if the galaxy is massive, if the dark matter halo extends far out into the void, then the streams will be tightly bound. They will wrap around us in specific calculable arcs. They will move at speeds that reveal exactly how much invisible mass is pulling on them. Think of a stellar stream as a dotted line tracing the contour of gravity. By measuring the speed and direction of thousands of stars within these streams, astronomers could reverse engineer the gravitational field they were traveling through. It was like watching leaves floating on a river to map the currents of the water beneath. The leaves reveal the invisible flow. The stars reveal the invisible mass. And what the streams revealed was undeniable. They were orbiting a giant. The Sagittarius stream is the most spectacular example of this cosmic tragedy. It is the remnant of the Sagittarius dwarf elliptical galaxy, a small satellite that began falling into the Milky Way billions of years ago. It is still falling today, in the final stages of being digested. The stream of stripped stars created by this collision is colossal. It wraps around the entire Milky Way, looping over the north galactic pole and diving under the south, tying a ribbon of light around our galaxy like a gift. It contains hundreds of millions of stars, stretching out across a diameter of hundreds of thousands of light years. When scientists mapped the full extent of the Sagittarius stream, they found something that shattered the old textbooks. The stream did not fade away at the 100,000 light-year mark. It kept going. It remained gravitationally bound to the Milky Way at distances that were previously thought to be empty intergalactic space. The stars in the stream were not escaping. They were held firm by a gravitational grip that extended far, far beyond the visible spiral arms. The mere existence of the Sagittarius stream at these distances proved that the Milky Way's mass influence was enormous. We were claiming territory in the void that belonged to no other galaxy, but Sagittarius was just the beginning. As telescopes like the Gaia spacecraft and the upcoming surveys from instruments like the James Webb Space Telescope peer deeper into the halo, they are finding more streams, fainter streams, older streams. The Orphan Stream, a thin, delicate wisp of stars orbiting far out in the halo, was named because we could not find its parent galaxy. It is likely that the parent was completely destroyed billions of years ago, eaten down to the last star, leaving only this orphan river flowing in the dark. The Orphan Stream extends out to distances that make the old maps look laughable. It probes the outer limits of the dark matter halo, and its path confirms that the invisible scaffolding of our galaxy is vast and complex. Then there is the GD1 stream, a narrow, cold stream of stars that looks like a scratch across the sky. It is incredibly long and incredibly thin, which makes it a perfect gravitational sensor. Any disturbance, any lump in the dark matter halo, would kink the stream like a bent wire. By studying GD1, astronomers have found gaps. places where the stream seems to have been punched through by something massive and invisible. Some theories suggest these gaps were caused by clumps of dark matter, silent subhalos orbiting within the larger structure, invisible bullets passing through a river of light. These streams are the reason we now know the Milky Way is 200,000 light-years across, or perhaps even larger. They are the boundary markers. They are the buoys floating in the deep ocean, showing us where the currents of our galaxy finally give way to the stillness of the intergalactic void, and they tell us that the void is much farther away than we thought. The edge of the galaxy is not a wall. It is a transition zone populated by the ghosts of devoured worlds. It is a haunting realization. We live in a graveyard. The beautiful, glowing arch of the Milky Way is built on a foundation of destruction. Every time you look at the stars, you might be looking at a refugee from a galaxy that died to make ours larger. The heavy elements in your blood, the iron, the calcium, or the carbon, might have been forged in the heart of a star that was born in the Sagittarius dwarf, ripped away from its home, and eventually exploded as a supernova in our own spiral arm, seeding the cloud that became our solar system. We are not just residents of the Milky Way. We are composed of the spoils of its conquests. If you are finding a strange, quiet comfort in the vastness of these cycles, in the idea that destruction and creation are just two sides of the same cosmic coin, take a moment to signal that connection. It helps this story reach others who are looking for their place in the dark. But do not break your stillness. Stay in the flow of the narrative. Because the story of the streams leads us to an even deeper mystery. We have established that the galaxy is huge. We have established that it is surrounded by a massive dark matter halo. We have used the corpses of other galaxies to map its size. But there is a problem with the speed. When we look at the stars that are native to the Milky Way, not the immigrants from other galaxies, but the ones born here in the outer disk, we see them doing something impossible. We see them skating on the edge of the abyss. Imagine a figure skater spinning on ice. As she pulls her arms in, she spins faster. As she extends her arms, she slows down. This is the conservation of angular momentum. It is a fundamental law of physics. In a galaxy, the mass is concentrated in the center, so as you move outward, the stars should slow down. They should be lazy, drifting wanderers at the edge of the disk. But they are not. The stars at the new, extended edge of the Milky Way are moving at velocities that defy this logic. They are sprinting. They are orbiting at hundreds of miles per second, speed so high that, by all rights, they should break free from the galaxy's grip entirely. This is the flat rotation curve problem, the anomaly that led to the discovery of dark matter in the first place. But with a galaxy twice the size, the problem becomes twice as complex. These outer stars are moving so fast that they are barely, just barely, hanging on. They are teetering on the razor's edge between belonging to the Milky Way and being flung out into the lonely void between galaxies. What keeps them here? It is not just the dark matter halo. It is the specific distribution of that dark matter. The halo must be denser, heavier, and more concentrated in the outer regions than our simulations predicted. The invisible cage is stronger than we thought. It has to be. If it weren't, the Milky Way would be shedding stars like water spinning off a bicycle tire. But even with the dark matter, some of these stars are moving at speeds that challenge our models. They are called hypervelocity stars, objects that are traveling so fast they will eventually escape the galaxy. They are the ones that will leave. They are the travelers who will punch through the invisible wall and journey into the true nothingness. Most of these hypervelocity stars were kicked out by the supermassive black hole at the galactic center, flung outward like stones from a slingshot. But some of them are found in the stellar streams, remnants of the violent tidal forces that tore their parent galaxies apart. So we have a picture of the Milky Way that is far more dynamic and terrifying than the static spiral in the textbook. It is a galaxy surrounded by a turbulent, invisible ocean of dark matter. It is wrapped in the ribbons of dead galaxies. It is holding onto its outer stars with a gravitational grip that is strained to the breaking point. And it is expanding, not just in our understanding but in reality. The Milky Way is still eating. It is still pulling in matter from the intergalactic medium. It is still growing. The large and small Magellanic Clouds, two of our most famous satellite galaxies, visible to the naked eye in the southern hemisphere, are next on the menu. For a long time, astronomers thought they might be just passing through, visitors interacting with us for the first time. But the new mass measurements change everything. With a galaxy twice as heavy, our gravity is twice as strong. The Magellanic Clouds are not visitors. They are captives. They are trapped in an orbit they cannot escape. They are already losing gas to us. The Magellanic Stream is a bridge of hydrogen gas stretching from them to us, a feeding tube siphoning their lifeblood into the Milky Way. In a few billion years, they will be gone. They will be ripped apart, just like Sagittarius, just like Gaia Enceladus, just like the orphan galaxies before them. Their stars will become streams. Their gas will fuel new star formation in our disk. They will cease to be neighbors and become part of the structure itself. This is the nature of the cosmos. It is not a place of permanence. It is a place of transformation. The boundaries we draw are temporary. The objects we name are fleeting. Even the Milky Way itself, this colossal, 4 trillion solar mass empire, is not the final state of things. It is just a phase. It is a momentary gathering of light and dark before the next great merger. And this realization brings us to the edge of the map. We have looked at the light and found it wanting. We have looked at the gravity and found it overwhelming. We have looked at the streams and found a history of violence. Now, we must look at the empty space beyond. If the Milky Way is bigger, then the space between us and everything else is smaller. The void is shrinking. The great, dark oceans separating the islands of the universe are drying up. And that changes the most fundamental question of all. Where does our galaxy end and the rest of the universe begin? The answer, as we are finding, is that there is no line. There is no wall. There is only a fading, a gradual, silent dissolution into the deep. And in that transition zone, where the gravity of the Milky Way finally gives way to the expansion of the universe, lies a stillness that is absolute. A silence so profound that it drowns out the violence of the cannibal history we have just uncovered. Let us drift toward that silence now. Let us move past the streams, past the speeding stars, and out into the region where the map simply stops. Drift out with those stars, out into the staggering expanse where the familiar map of the spiral arms simply dissolves into nothingness. Out here, at the absolute extremity of the dark matter halo, we encounter a physical paradox that breaks our intuitive understanding of how the universe is supposed to operate. We find ourselves in a region where the foundational laws of orbital mechanics seem to fray, bending under the weight of an invisible reality. To comprehend the strangeness of this boundary, you first must understand the comforting predictability of the physical laws that govern our immediate neighborhood. In our solar system, there is a beautiful, mathematical harmony to the way things move. Isaac Newton mathematically defined it centuries ago, and Johannes Kepler observed it even earlier. The rule is elegantly simple. The closer an object is to a massive central body, the faster it must move to avoid being pulled inward and consumed. Mercury, the scorched and battered world closest to our sun, is locked in a frantic race against the crushing gravity of the star it orbits. It whips around the sun at nearly 30 miles every single second, completing its entire year in a mere 88 days. It has to move with this blistering speed. If it slowed down even slightly, the sun's immense gravitational pull would drag it down into the nuclear furnace. But as you travel outward, away from the intense heat and the overwhelming mass of the sun, the gravitational leash begins to slacken. The grip weakens. By the time you reach the cold, twilight realm of Neptune, billions of miles away from the center, the urgency is entirely gone. Neptune is a slow, frozen wanderer, drifting along its orbital path at a leisurely 3 miles per second. It takes 165 Earth years to complete a single lonely revolution. This is the natural, expected order of a gravitational system. Mass dictates power, and distance dilutes that power. For a very long time, astronomers confidently assumed that entire galaxies must behave in exactly the same way. A galaxy is, after all, just a scaled-up version of a solar system, a vast collection of mass swirling around a dense, heavy center. We expected that the stars packed tightly in the glowing core of the Milky Way would be whipping around at tremendous velocities, fighting the immense combined gravity of the supermassive black hole and the dense nuclear star cluster. And conversely, we expected that the stars located far out on the fringes, the lonely outposts at the very edge of the visible disk, would be moving slowly, tracing lazy, majestic arcs through the dark, feeling only a whisper of the gravity from the distant center. But when the instruments finally became sensitive enough to measure the velocities of these extreme outer stars, the data revealed a terrifying anomaly. The stars at the edge of the galaxy were not slowing down. The majestic, lazy drift we expected to find simply did not exist. Instead, the rotation curve of the galaxy remained perfectly flat. The stars residing tens of thousands of light years away from the galactic center were orbiting at nearly the exact same speed as the stars located relatively close to the core. This was the initial shocking clue that led to the realization of the dark matter halo. To keep these fast-moving outer stars from flying off into the void, there had to be millions of times more mass hidden in the darkness than we could see in the light. However, as we pushed our measurements even further outward, tracking stars not just at the edge of the visible disk, but deep into the diffuse outer halo, the situation evolved from merely puzzling to profoundly extreme. Out here, at distances of 150,000 or even 200,000 light-years from the center, we find a population of solitary ancient stars doing something entirely counterintuitive. They are moving at velocities that are frankly terrifying. We observe halo stars tearing through the absolute zero vacuum of space at 130 miles per second. We track others clocking in at 150 miles per second. Some rare blazing wanderers are recorded moving at nearly 200 miles per second. According to every model we have, they should not be there. At these immense distances, the gravitational pull of the Milky Way, even when factoring in the colossal 4 trillion solar mass weight of the dark matter halo, is stretched incredibly thin. The tether holding these stars to our galaxy is stretched to its absolute breaking point. At these extreme velocities, these stars are skating on the very edge of the abyss. In astrophysics, there is a critical threshold known as escape velocity. It is not a theoretical concept. It is a hard mathematical boundary. Escape velocity is the exact, specific speed an object must achieve to perfectly overcome the gravitational binding energy of the mass it is orbiting. If you throw a stone straight up into the air, it slows down, stops, and falls back to Earth because you did not give it enough kinetic energy to defeat the planet's gravity. But if you could throw that same stone upward at roughly 7 miles per second, it would never come back down. It would break the invisible chain and coast outward into the solar system forever. Every point in the galaxy has a specific escape velocity, determined by how much mass lies interior to that point. Deep in the core, the escape velocity is unimaginably high. Out in the distant halo, it drops significantly. And this is where the behavior of these edge stars becomes truly mesmerizing. We have found stars orbiting in the deep halo, where the local escape velocity is calculated to be roughly 200 miles per second. And the stars themselves are moving at 198 miles per second. They are 2 miles per second away from absolute, permanent freedom. They are existing in a state of almost perfect kinetic tension. One minor gravitational nudge from a passing dark matter clump, one slight transfer of momentum, and they would cross that threshold, severing their ties to the Milky Way forever and becoming rogue stars condemned to drift alone through the endless intergalactic void. But they do not. They remain bound, skating endlessly on the razor-thin ice of that gravitational limit, trapped in a delicate, high-speed balancing act that has lasted for billions of years. Imagine, for a moment, the profound isolation of standing on the surface of a hypothetical rocky planet orbiting one of these edge stars. You are standing on a world that is hurtling through the dark at incomprehensible speeds, yet the sensation around you is one of absolute, deathly stillness. Because you are so incredibly far from the center of the galaxy, the night sky above you looks nothing like the star-studded canopy we see from Earth. The sky of this edge world is mostly a terrifying, featureless black. The stars of the Milky Way are not scattered evenly across the heavens. They are gathered together in a single, distant, glowing smudge, a pale and ghostly spiral viewed entirely from the outside looking in. You would be looking at the entirety of your home galaxy as an external object, a massive, softly glowing island suspended in an infinite ocean of nothingness. The light reaching your eyes from the far side of that spiral left its source hundreds of thousands of years ago, before your species even existed. You are connected to that glowing island by the thinnest, most fragile thread of gravity imaginable, a phantom tether stretching across 1,000,000 trillion miles of empty space. The loneliness of such a vantage point is absolute, yet there is a deep, resonant peace in it. You are removed from the chaos, the radiation, the violent supernovae, and the stellar collisions of the inner disk. You exist in the quiet periphery, untouched and undisturbed, floating on the boundary between something and nothing. How did these stars achieve such precarious, terrifying speeds? They did not form out here in the quiet dark. The outer halo is too sparse, too cold, and too diffuse to allow the vast clouds of hydrogen gas to compress and ignite into new stars. These fast-moving sentinels are immigrants. They are the survivors of unimaginable violence. Some of them are the direct result of the galactic cannibalism we discussed earlier. When a dwarf galaxy is captured and shredded by the Milky Way, the immense tidal forces do not just pull the stars apart. They inject a massive amount of kinetic energy into the system. The stars from the dying dwarf galaxy are violently accelerated, whipped around the gravitational center of our galaxy like stones launched from a sling. Many of those stars are thrown with so much energy that they immediately exceed the escape velocity and are banished from the Milky Way entirely, becoming true hypervelocity stars shooting out into the intergalactic darkness. But a small fraction of them receive just slightly less energy than required for total escape. They are flung outward, traveling hundreds of thousands of light years away from the chaotic collision zone, their speed slowly, gradually bleeding away as they fight the backward pull of the dark matter halo. By the time they reach the extreme outer edges, their outward momentum is perfectly balanced by the inward pull of gravity. They settle into these vast, highly elliptical orbits, forever carrying the residual speed of the ancient catastrophe that tore their original home apart. They are the cosmic debris of a war fought billions of years ago, frozen in a state of perpetual, high-speed exile. Other fast-moving stars in the halo might have a different, even more dramatic origin story. Deep within the heart of the Milky Way, buried behind impenetrable walls of glowing gas and dust, sits Sagittarius, a star, the supermassive black hole that anchors our galaxy. This object contains the mass of 4 million suns crushed into a singularity. Occasionally, a binary star system, two stars tightly orbiting one another, will wander too close to the event horizon of this monster. The gravitational physics of this encounter are brutal and uncompromising. The black hole will often capture one of the stars, tearing it away from its partner and dragging it down into the accretion disk to be consumed. But to conserve the angular momentum of the system, the other star is violently rejected. The surviving star is kicked outward with a sudden catastrophic transfer of energy, accelerating to millions of miles per hour in a matter of hours. These are the true hypervelocity stars, objects moving so fast they draw a straight line out of the galaxy, completely ignoring the gravitational pull of the dark matter halo. We have tracked several of these escaping stars, tracing their trajectories perfectly back to the central black hole. But again, statistics dictate that occasionally a star receives a kick that is powerful, but not quite powerful enough. It is thrown from the core, it travels for millions of years through the disk, punches through the inner halo, and finally runs out of outward momentum right at the absolute edge of the dark matter boundary, settling into a long, solitary orbit, a refugee from the most violent environment in the galaxy, now condemned to the quietest. There is another, more subtle theory that explains why so many stars seem to cluster at these high, barely bound velocities. It involves the very texture of the dark matter itself. Our computer simulations often model the dark matter halo as a perfectly smooth, symmetrical sphere, smoothly decreasing in density the further out you go. But nature rarely operates with perfect symmetry. The halo is likely textured, lumpy, and chaotic. It was built up over billions of years through the merging of countless smaller dark matter halos, and those mergers leave scars. There are likely localized concentrations of dark matter, invisible mountains and ridges of mass drifting slowly through the outer halo. If a star happens to fall into a resonant orbit with one of these invisible dark matter structures, it can be accelerated. It surfs the gravitational contours of the unseen mass, picking up speed from the complex, multi-body interactions. The star becomes trapped in a dynamic balance, moving at velocities that seem impossible because we cannot see the invisible architecture that is pushing and pulling it. It is like watching a leaf moving against the current of a river, propelled by an underwater eddy that remains completely hidden beneath the surface. The fast stars are tracing the invisible topography of the dark matter halo, mapping the unseen mountains of our home. This tension, this perfect balance between the overwhelming desire to fly apart and the subtle, invisible force pulling everything together, is the defining characteristic of the cosmic edge. It is a place of profound precariousness, where the difference between being part of a 4 trillion solar mass empire and being a solitary wanderer in an infinite void comes down to a few miles per second. There is a deeply hypnotic quality to contemplating this balance. Imagine allowing your own thoughts, your own tensions, your own anxieties to mimic the trajectory of those edge stars. Feel them being thrown outward, away from the dense, noisy, chaotic center of your waking mind. Watch them travel further and further out into the quiet periphery, their speed slowly bleeding away, their urgency fading. Allow them to reach that boundary layer, that frictionless zone, where the pull of the day finally matches the momentum of the night, and they simply hover, suspended in the dark. You are skating on the abyss now. The heavy, solid reality of the waking world is far behind you, a distant, glowing smudge that no longer holds any immediate power over you. You are held only by the thinnest tether of awareness, drifting in the vast, quiet space where the boundaries blur, and the momentum of the day finally surrenders to the stillness of the void. There is no need to fight the gravity, and no need to force the escape. You are simply floating on the equilibrium, perfectly balanced on the razor-thin edge between consciousness and the deep, silent expanse of sleep. Allow the quiet isolation of the outer halo to wash over you, knowing that out here, in the extreme distance, there is nothing left to collide with, nothing left to hold on to, just the smooth, endless glide through the dark. To understand what a larger Milky Way truly means, we have to stop looking at the galaxy itself for a moment and turn our attention to the emptiness that surrounds it. We have to look at the void. For centuries, human beings have conceptualized the universe as a vast, overwhelming ocean of nothingness, punctuated by tiny, isolated islands of light. We called these islands galaxies, and we believed they were separated by millions of light years of absolute, dead silence. We thought of the universe as a place defined by its emptiness, where matter was the exception and the void was the rule. But if the Milky Way is double the size we thought, and if Andromeda and every other spiral galaxy are also significantly larger, then the fundamental geometry of that void changes. It is a zero-sum game of cosmic real estate. If the islands get bigger, and the ocean gets smaller, the emptiness is shrinking. When we redraw the boundaries of our home, pushing the edge of the Milky Way out to 200,000 light-years or more, we are effectively claiming territory that we previously thought belonged to the intergalactic medium. We are annexing the void, The seemingly empty space between us and Andromeda is not merely a gap, it is a borderland, and that borderland is rapidly disappearing. We used to think of our nearest galactic neighbor as a distant object, a separate entity resting safely across a chasm of darkness. Now, we realize that the chasm is shallow. The dark matter halos of our two galaxies may already be touching, their invisible fingers intertwining in the deep dark. The void between us is no longer a barrier. It is a bridge. But this expansion of territory does something even more disquieting. It forces us to redefine the very center of our existence. In every diagram of the Milky Way you have ever seen, there is a bright glowing dot in the middle labeled galactic center. We are taught that everything in the galaxy orbits this point. We are told that sitting at the exact heart of this rotation is Sagittarius A star, the supermassive black hole 4 million times the mass of the Sun. It is a comforting, heliocentric style model applied to a galactic scale. The black hole is the king, the anchor, the immovable pivot point around which the entire disk spins. But nature is rarely that symmetric, and it is never that simple. The Milky Way spins around a point called the center of mass, or the barycenter. In a perfectly balanced system, the center of mass and the geometric center would be the same place. If the galaxy were a perfect, uniform dinner plate spinning on a finger, the balance point would be right in the middle. But the Milky Way is not a perfect plate. It is a lumpy, scarred, chaotic collision of structures. It has a massive bar of stars slashing through its core. It has spiral arms that are denser in some places than others. And most importantly, it has satellite galaxies, heavy, massive companions like the Large Magellanic Cloud that are dragging on it. The Large Magellanic Cloud is not just a speck of dust orbiting a planet. It is a substantial galaxy in its own right, perhaps 10% of the mass of the Milky Way. As it orbits us, its gravity pulls back. It tugs on the Milky Way's dark matter halo. It distorts the disk. This gravitational interaction shifts the true center of mass away from the supermassive black hole. The entire galaxy, black hole included, is actually orbiting a point in empty space that is offset from the visible core. We are wobbling. The Milky Way is doing a slow, cosmic hula hoop motion around a center of gravity that is constantly shifting as satellite galaxies orbit and merge. This realization, that the center is not a fixed object, but a mathematical point in the dark, adds a layer of vertigo to our understanding of the cosmos. The anchor we thought was holding us is actually drifting. The black hole itself is surfing through the central region of the dark matter halo, sloshing back and forth as the galaxy responds to the gravitational pull of its neighbors. Nothing is static, nothing is fixed. Even the heart of the galaxy is a traveler. And as we move outward from that shifting center, back into the shrinking void, we have to confront the nature of the nothingness itself. What exactly is the intergalactic medium? If you were to teleport instantly to a point halfway between the Milky Way and Andromeda, what would you find? You would be outside the viral radius of either galaxy, floating in the deep abyss. For a long time, we thought you would find a vacuum so perfect it defies simulation, a few atoms of hydrogen per cubic meter, maybe a wandering photon, essentially zero. But the larger mass estimates of galaxies suggest that the intergalactic medium is not empty. It is polluted. It is thick with the debris of billions of years of galactic interactions. It is filled with a tenuous, hot web of gas called the warm-hot intergalactic medium, or WIM. This is not the cold, dense gas that forms stars. It is a diffuse plasma, heated to millions of degrees by the shock waves of structure formation. It is invisible to optical telescopes, invisible to radio telescopes, and barely detectable by X-ray observatories. But it is there. It accounts for a huge portion of the missing matter in the universe. The space between galaxies is also populated by rogue stars. These are the exiles we spoke of earlier, the ones that achieved escape velocity. But for every star that almost escapes and stays in the halo, there are countless others that actually succeed. They punch through the boundary and sail out into the dark. There could be billions of rogue stars drifting in the void between the Milky Way and Andromeda. Entire solar systems, perhaps with planets, perhaps with life, floating in absolute isolation, light years from the nearest galaxy. To a civilization on such a planet, the night sky would be perfectly black, devoid of stars, with only the faint, fuzzy patches of distant galaxies to mark the passage of time. They would think the universe was truly empty. They would have no concept of a Milky Way or an Andromeda, only the lonely, infinite dark. But even they are connected to the web. The universe is structured like a sponge. Galaxies are not scattered randomly. They are arranged in filaments, long threads of dark matter and gas that stretch across the cosmos. These filaments connect massive clusters of galaxies, forming a skeleton of the universe. The Milky Way sits in a localized sheet, a small spur of this great web. The voids are the empty bubbles between the filaments. By realizing our galaxy is larger and our dark matter halo is more extensive, we are realizing that the filaments are thicker than we thought. The connecting tissue of the universe is more robust. We are not an island. We are a knot in a vast, invisible net. This changes how we must think about our future. We often talk about the isolation of humanity, stuck on Earth, stuck in the solar system, stuck in the galaxy. We fear the vast distances. But if the galaxy is larger and the voids are filled with dark matter substructures and gas, the universe is far more interconnected than we imagined. The empty space is actually a medium through which gravity, matter, and energy are constantly flowing. We are part of a continuous system. Consider the Great Attractor. It is a gravitational anomaly located hundreds of millions of light years away in the direction of the Centaurus constellation. Something massive is over there. Something so heavy that it is pulling the Milky Way, Andromeda, and thousands of other galaxies toward it at millions of miles per hour. We are all flowing like water down a drain toward this mysterious point. If the Milky Way is more massive, our interaction with this great flow changes. Our momentum is different. Our resistance to the pull is different. We are a heavier boat in the same river, which means we navigate the current differently. The recalculation of our galaxy's size forces a recalculation of the entire local universe. It affects the mass estimates of the local group. It affects the dynamics of the Virgo supercluster. Here's the massive city of galaxies to which our suburb belongs. It affects the definition of Laniakea, the immeasurable heaven, the supercluster of superclusters that we call home. Every time we add a zero to the size of the Milky Way, we have to adjust the balance of the entire hierarchy of cosmic structure. But let's return to the personal scale. Let's return to the feeling of the void. There is a specific kind of fear associated with deep space, the fear of falling forever into nothing. It is a primal fear of the abyss. But the new map of the Milky Way offers a different perspective. You are not standing on the edge of a cliff overlooking a drop into nothingness. You are standing in a dense, rich forest that simply thins out. The void is just a clearing in the forest. It is still part of the ecosystem. It is still grounded. The darkness is not an absence of things. It is a presence of things we cannot see. The dark matter halo that extends out to touch Andromeda is like an atmosphere. We are breathing the same air as our neighbor. We are touching them before we even meet them. The collision has already begun in the dark. The silence of space is not the silence of emptiness. It is the silence of a held breath. It is the quiet of a room that is full of people waiting for something to happen. There is a profound intimacy in this crowded universe. If the voids are shrinking, then we are closer to everything. The distances are still vast, yes. Light still takes millions of years to travel. But gravitationally, structurally, we are intimate. We are locked in a dance with everything around us. The Milky Way feels the tug of Andromeda. It feels the drag of the Magellanic Clouds. It feels the distant call of the Virgo cluster. It feels the relentless pull of the Great Attractor. We are being touched by the gravity of 1 trillion worlds every second. So, as you lay there, visualize the space around Earth not as a vacuum, but as a fluid. A dark, invisible, heavy fluid of dark matter and tenuous gas. We are swimming in it. The Earth is a submarine navigating the currents of this halo. The solar system is a bubble of light moving through the deep pressure of the galaxy, and the galaxy itself is a leviathan moving through the cosmic ocean. There is no empty space. There is no outside. There is only the continuous, unbroken fabric of the cosmos, stretching from the atoms in your body to the edge of the observable universe. This perspective shifts the nature of our loneliness. We are not lonely because we are isolated in a desert. We are lonely because we are in a crowded room and haven't figured out how to talk to anyone yet. But the room is definitely crowded. The sheer amount of stuff out there, dark matter, gas, rogue stars, dust, is staggering. The universe is heavy. It has weight. It has substance. And that substance is holding you right now. The gravity that keeps your feet on the ground is just a local manifestation of the same force that binds the halo, that pulls the streams, that links the galaxies. You are pinned to the Earth by the curvature of space-time, and that curvature is continuous. You are connected to the center of the galaxy and to the edge of the halo and to the great attractor beyond. You are woven into the tapestry. And if you want to understand that tapestry, if you want to keep tracing these invisible threads into the dark, there is a simple way to stay connected to this signal. You know what to do. A small gesture in the dark, a silent acknowledgement of the journey we are taking. Join us as we continue to map the unmapped. Because the map keeps changing. The void keeps filling up. And the more we look, the more we find that there is no such thing as empty space. There is only the waiting dark. Now let us turn our attention to the inevitable. We have spoken of the shrinking void and the touching halos. But what happens when the touch becomes a grasp? What happens when the gravitational flirtation between two giants turns into a violently beautiful marriage? We have to talk about Andromeda. We have to talk about the future that is rushing toward us at 70 miles per second. Because if the Milky Way is bigger, the collision is not just a theory. It is a rapidly accelerating reality. And the timeline for the end of our world as we know it has just moved up. Turn your gaze now to the constellation Andromeda. If you are in the northern hemisphere and the sky is dark enough, you can see it with your naked eye. It appears as a faint, fuzzy smudge of light, a ghostly thumbprint on the black canvas of the night. It looks small. It looks insignificant. It looks silent. But appearances are the most dangerous deception in astronomy. That faint smudge is a spiral galaxy containing 1 trillion stars. It is 2.5 million light-years away, and it is hurtling toward us at 70 miles per second. For decades, we looked at Andromeda as a distant neighbor, a separate island universe floating safely across the cosmic ocean. We calculated the distance, measured the speed, and predicted a collision in the far-distant future, roughly 4.5 billion years from now. It was a problem for another sun, another Earth, another species. But the realization that the Milky Way is significantly larger, heavier, and more expansive changes the timeline of this apocalypse. It shifts the mechanics of the inevitable, and it forces us to confront the possibility that the collision has, in a very real sense, already begun. If we underestimated the size of our own galaxy due to the limitations of our perspective, logic dictates we have likely underestimated Andromeda as well. When we look at Andromeda, we see its bright stellar disk, the glowing spiral arms where stars are born. But just like the Milky Way, Andromeda is encased in a massive, invisible sphere of dark matter. If our halo extends 200,000 light-years or more, Andromeda's halo, which belongs to a galaxy historically considered even more massive than ours, likely extends even further. Imagine 2 giant soap bubbles drifting toward each other. The visible galaxies are just tiny specks of dust floating in the very center of those bubbles. The bubbles represent the dark matter halos. Long before the specks of dust touch, the surfaces of the bubbles meet. The outer edges of the gravitational influence interact first. With the revised size estimates, the math becomes claustrophobic. If the Milky Way's halo reaches out for 1 million light-years, and Andromeda's reaches out for 1 million light-years, and the distance between us is only 2.5 million light-years, there is very little breathing room left. In fact, recent studies of the gas in the intergalactic medium suggest the halos are already overlapping. We are not just looking at Andromeda, we are physically touching it. The dark matter of our galaxy is currently mingling with the dark matter of theirs. The outer gas clouds are already feeling the pressure. The silent convergence is underway. This changes the narrative of the collision from a future event to a current process. We are living in the opening act of a galactic merger. It is a slow-motion catastrophe, unfolding over timescales so vast that human history is less than a blink of an eye. But it is happening. And because the galaxies are more massive than we thought, the gravity pulling them together is stronger. The 70 miles per second approach speed will increase. As the halos overlap more, the drag increases. The galaxies will fall toward each other faster. The collision timeline shrinks. It might not be 4 billion years, it might be 3 or less. But what does a galactic collision actually look like? The word collision brings to mind car crashes, explosions, the violent shattering of glass and metal. But galaxies are mostly empty space. The distance between stars is immense. If the sun were a ping-pong ball in New York, the nearest star would be another ping-pong ball in Chicago. When two galaxies collide, the stars almost never hit each other. They simply pass through the gaps. It is not a crash, it is a ghost dance. The first thing to interact will be the gas. As the visible disks of the Milky Way and Andromeda plow into each other, the vast clouds of interstellar hydrogen will slam together. Unlike stars, gas clouds are large and diffuse. They cannot miss each other. They will compress, heat up, and ignite. The collision will trigger a period of furious star formation. Millions of new suns will burst into life all at once, lighting up the wreckage with a brilliance that will outshine the rest of the galaxy. It will be a firework display on a cosmic scale, a final burst of creative energy before the long silence. Then comes the gravitational chaos. As the heavy cores of the galaxies swing past each other, their gravity will whip the stars into wild, frenzied orbits. The beautiful, orderly spiral arms of the Milky Way will be torn apart. The grand design will be shredded. Long tails of stars will be flung out into the void, tidal streamers stretching for hundreds of thousands of light years, carrying millions of solar systems into the cold dark. Some stars will be ejected entirely, lost to the intergalactic night. Others will plunge toward the central supermassive black holes. Imagine the view from Earth, assuming our planet survives long enough to witness it. The sun will be aging, growing hotter and brighter as it burns through its fuel. But the night sky will be transforming. Andromeda will grow larger and larger, eventually dominating the heavens. It will cease to be a smudge and become a distinct spiral, vast and detailed, hanging over the horizon like a second ominous Milky Way. As the merger accelerates, the band of our own galaxy will warp and twist. The two spirals will cross, creating an X shape of fire across the sky. The darkness will be filled with the blue light of newborn stars and the red glow of ancient giants being tossed around like leaves in a storm. It will be the most beautiful thing ever seen in the local universe. A majestic, terrifying ballet of 4 trillion suns rearranging themselves. And it will be entirely silent. There is no air in space to carry the sound of the crashing gas or the screaming gravity. The destruction of our home will happen in absolute, reverent silence. Eventually, the two galaxies will lose their momentum. They will stop rushing past each other and fall back together, merging their cores. The supermassive black holes, Sagittarius A star, and the monster at the heart of Andromeda will spiral inward. They will begin a death dance of their own, radiating gravitational waves that ripple through the fabric of space-time, shaking the universe itself. Finally, they will merge into a single titanic singularity. The spiral structures will be gone forever. The chaos will settle. The star formation will burn itself out. What remains will be a single, gigantic elliptical galaxy. A vast, amorphous ball of old, red stars, buzzing around a central core like bees in a hive. Astronomers have already named this future galaxy. They call it Milkomeda, a portmanteau of the parents, a name for the child of the collision. Milkomeda will be a monster. It will contain the mass of both giants, plus the debris of all the smaller satellite galaxies like Triangulum and the Magellanic Clouds, which will also be swept up in the chaos. It will be an island of trillions of stars, drifting alone in an expanding universe. Because as this merger happens, the dark energy driving the expansion of the universe will be pushing all the other galaxies away from us. The local group will be bound together by gravity, but the rest of the cosmos will recede beyond the cosmic horizon. In the far, far future, looking up from a planet inside Milkomeda, you would see nothing but the stars of your own galaxy. No other galaxies, no background radiation, just the eternal, static globe of stars you live in, surrounded by an infinite, empty black. The evidence of the Big Bang, the evidence of expansion, the evidence of other island universes will all have drifted away. Future astronomers in Milkomeda might conclude that their galaxy is the entire universe, the only thing that has ever existed, floating in a void that has no end. But let us pull back from that distant, lonely future and return to the mechanics of the now. The fact that the Milky Way is bigger means this process is governed by more mass. More mass means the final galaxy, Milkomeda, will be more compact, more dense. The stars will be packed tighter. The night sky of the future will be brighter. And what of us? What of the solar system? The sun orbits the galactic center once every 230 million years. We are currently in a stable, quiet orbit. But when the merger happens, stability is the first casualty. The sun could be flung into the deep core, where the radiation is intense and the stellar density is dangerous. Or more likely, we could be flung outward. We could be one of those systems exiled to the tidal tails, drifting far away from the heart of the new galaxy. There is a poetic irony in this. Just as the sun enters its final years, swelling into a red giant that will consume Mercury and Venus and scorch the Earth, the galaxy itself will be dying and being reborn. The death of our star will coincide with the death of our galaxy's structure. We will go out witnessing the greatest event in local cosmic history. But there is another possibility, one that the new mass estimates make more plausible. If the Milky Way is truly massive, if its gravity is as dominant as the new data suggests, we might not merge with Andromeda as equals. We might be the dominant partner. For a long time, Andromeda was thought to be the heavyweight. But if the Milky Way is actually the more massive of the two, or if we are at least peers, the dynamics of the collision change. We might absorb them. We might survive with more of our structure intact. The geometry of the crash depends entirely on the invisible mass of the halos. We are watching a car crash in extreme slow motion, but we are still arguing about the weight of the cars. And until we map the full extent of that dark matter halo, until we trace the velocity of every distant satellite galaxy, we cannot predict the exact shape of the wreck. We only know that it is coming. We only know that gravity wins. This convergence brings us back to the feeling of connectedness. We are not isolated. We are gravitationally married to Andromeda. The rings are already on the fingers, touching in the dark. The engagement was announced billions of years ago by the laws of physics. We are just now realizing that the wedding date has been moved up. There is a comfort in this too. A reminder that nothing in the universe is static. Stability is an illusion created by our short lifespans. On the scale of the cosmos, everything is flowing, merging, changing, and evolving. The Milky Way is not a place. It is a process. It is a river of stars flowing toward a confluence with another river, and we are just a drop of water in the current. To fear the collision is to misunderstand the nature of space. It is not destruction. It is integration. It is the universe organizing itself into larger and larger structures. It is the gravity that built the stars now building something greater than a galaxy. As you visualize this slow, silent approach, imagine the sheer scale of the forces at work. 4 trillion suns pulling on 4 trillion suns. the invisible fabric of space-time stretching and warping, the great halos sliding through each other like clouds. It is a spectacle of pure physics, playing out in the quiet theater of the void. And you are here, in the front row, watching the prologue. But even as we accept the fate of Milky, even as we redraw the maps and reschedule the apocalypse, there is a nagging problem. A problem that arises from the very numbers we are using to predict this future. We keep saying the Milky Way is massive. We keep saying it has 4 trillion solar masses of gravity. We see the effects of that gravity in the speed of the stars and the pull on Andromeda. But when we count the actual physical stuff we can see and touch, the normal matter, the atoms, the gas, the dust, it does not add up. If the galaxy is this heavy, it should have more normal matter. It should have more gas. It should have more stars. But it doesn't. We can find the dark matter, but we cannot find the normal matter that should accompany it. There is a gap in the ledger, a massive accounting error in the cosmic balance sheet. Where is the rest of us? Where is the missing half of the Milky Way's physical body? This is the missing baryon problem, and the larger the galaxy gets, the more embarrassing this problem becomes. We are missing half the ingredients of the recipe, and finding them requires us to look not at the stars and not at the dark matter, but at the empty spaces we just claimed were full. We have to look for the fog hiding in the dark. We have to look for the ghosts of atoms that are hiding in plain sight. Let us turn our detectors to the hidden reservoirs of the galaxy and try to find the missing matter before the merger scrambles the evidence forever. Imagine an auditor sitting in a dimly lit room, poring over the financial ledger of an empire that spans trillions of miles. The auditor's job is simple in theory, but impossible in practice. They must count every single coin, every asset, every fraction of value within the empire, and ensure that the total matches the known wealth of the sovereign. Now, replace the auditor with an astrophysicist, replace the coins with atoms, and replace the empire with the Milky Way. When we calculate the sheer gravitational authority of our newly expanded galaxy, we arrive at that staggering figure of 4 trillion solar masses. We know the gravity is there, holding the distant stellar streams in their delicate high-speed orbits. We know the dark matter accounts for the vast majority of that weight, when creating the invisible scaffolding we have already explored. But the laws of cosmology, written in the faint microwave radiation left over from the birth of the universe, dictate a very specific ratio between the invisible and the visible. The universe operates on a strict recipe. For every measure of dark matter, there must be a corresponding proportional measure of normal matter. In astrophysics, this normal matter is called baryonic matter. The word baryon might sound like an abstract, distant concept, but it is the most intimate and familiar substance in existence. Baryons are the protons and neutrons that form the nucleus of every atom. They are the building blocks of the physical world as you understand it. The oxygen you are breathing in this very moment is baryonic. The soft fabric resting against your skin, the iron coursing through your bloodstream, the glass and silicon of the device playing this audio, and the solid bedrock of the earth beneath your home are all made entirely of baryons. Every blazing star you can see in the night sky, every swirling cloud of neon gas in a distant nebula, and every frozen comet drifting through the outer solar system is constructed from this exact same material. Baryonic matter is the stuff of reality, the tangible, interactive, light-emitting, light-absorbing material that makes the universe beautiful and complex. According to the unyielding cosmic ratio established during the Big Bang, baryonic matter should make up roughly 15% of the total matter in any given galaxy. The math is straightforward, but the reality is deeply troubling. If the Milky Way possesses a total mass of 4 trillion suns, then simple arithmetic demands that we should be able to find roughly 600 billion solar masses of normal baryonic matter floating somewhere within our gravitational borders. So, the cosmic auditors set out to count the wealth. They use the most sophisticated optical telescopes to count the stars, estimating their varied masses, from the hyperactive blue giants to the smoldering ancient red dwarfs. They tally up the mass of the supermassive black hole at the center. They use radio telescopes to sweep the galactic disk, measuring the vast, cold clouds of molecular hydrogen that serve as the nurseries for future suns. They measure the swirling dust, the planetary nebulae, the white dwarfs, and the neutron stars. They count every single ounce of physical reality they can detect across the entire 200,000 light-year expanse of the visible galaxy, and when they finally add up the ledger, the numbers do not balance. They do not even come close. The grand total of all the stars, all the gas, all the dust, and all the planets in the Milky Way amounts to perhaps 100 to 200 billion solar masses. The rest is simply gone. We are missing hundreds of billions of suns' worth of physical material. We are missing half of our own galaxy. This is known as the missing baryon problem, and as we realized the Milky Way was twice as large as we thought, the scale of this embarrassment doubled along with it. A larger galaxy requires more dark matter, which in turn demands more normal matter, making the hole in our cosmic accounting even deeper. It is as if you walked into your house, found that half of the physical structure was supporting a second story you never knew existed, but entirely devoid of the wood, brick, and steel that should have been used to build it. Where does half a galaxy hide? How do hundreds of billions of solar masses of normal matter simply vanish from the ledger? They cannot turn into dark matter because the two substances are fundamentally different, separated by an unbridgeable chasm of quantum physics. The missing baryons must be out there, lurking somewhere within the expanded borders of our gravitational domain, invisible to our traditional methods of observation. For decades, astronomers formulated theories to explain the deficit and searching the dark corners of the Milky Way for the missing mass. One early theory proposed that the missing matter was hiding in the form of massive, compact halo objects. These were hypothesized to be dense, dark things drifting silently through the outer edges of the galaxy. We imagined swarms of brown dwarfs, objects too massive to be called planets, but not quite massive enough to ignite the nuclear fusion required to shine as stars. We pictured them as giant, smoldering spheres of gas, slowly cooling in the eternal night, emitting only the faintest whispers of infrared heat. We also looked for rogue planets, worlds that were formed in the chaotic disks of young star systems, but were violently ejected by gravitational interactions, condemned to wander the interstellar void without a sun to warm them. Imagine the profound isolation of a rogue Jupiter, a colossal gas giant sailing through the absolute zero vacuum of the deep halo, completely untethered from any star, surrounded by a darkness so complete it is almost tangible. These dark objects certainly exist. The James Webb Space Telescope, with its unprecedented sensitivity to infrared light, is currently peering into the deepest, coldest regions of the Orion Nebula and other star-forming regions, and it is finding these rogue worlds. It is discovering free-floating planets drifting in pairs, untethered from any stellar anchor, radiating the last remnants of their internal heat of formation. But as fascinating and haunting as these solitary wanderers are, there simply are not enough of them to balance the ledger. Even if there are trillions of rogue planets wandering the Milky Way, their combined mass is a mere drop in the cosmic ocean. They cannot account for the hundreds of billions of missing suns. The dark matter halo is not filled with a hidden swarm of dead stars and lost planets. The answer had to be something far more diffuse, far more elusive, and far larger in scale. If the missing matter is not locked up in dense dark objects, then it must be spread out. It must be a gas. But it cannot be the cold, dense molecular hydrogen that we easily detect in the galactic disk, because our radio telescopes would have seen it long ago. The missing baryons had to be existing in a state that renders them practically invisible to almost every instrument humanity has ever built. They had to be unimaginably hot and unimaginably thin. This realization led astronomers to look beyond the visible disk of the galaxy, out past the spiraling arms and the glowing nebulae, into the vast, seemingly empty volume of the dark matter halo itself. They hypothesized the existence of a circumgalactic medium, a colossal, spherical atmosphere of plasma completely engulfing the Milky Way. This is not an atmosphere like the one you are breathing. The circumgalactic medium is heated to temperatures of millions of degrees, existing in a state of highly ionized plasma where electrons have been violently stripped away from their atomic nuclei. But here is the beautiful, counterintuitive paradox of the hot gas halo. Although its temperature is measured in the millions of degrees, if you were somehow teleported into the middle of it without a spacesuit, you would not instantly burn to a crisp. In fact, you would rapidly freeze to death. Temperature, in the realm of astrophysics, is simply a measurement of how fast particles are moving. The particles in the circumgalactic medium are moving at incredible, blistering speeds, carrying immense thermal energy. But the density of the gas is so unfathomably low that it borders on a perfect vacuum. There might be only 1 or 2 atoms of this superheated plasma in an entire cubic meter of space. If you were floating out there, the hyperactive atoms would be striking your skin so infrequently that they could not transfer their heat to you fast enough to counteract the freezing void of space. This extreme, ghostly thinness is exactly why the circumgalactic medium remained hidden for so long. It is too diffuse to emit any visible light. It is too thin to block the light of background stars. It only reveals its presence by absorbing highly specific, incredibly faint wavelengths of X-ray and ultraviolet light from distant quasars as their beams pierce through our galactic atmosphere on their billions-of-year journey to Earth. By studying these infinitesimally small shadows in the light of distant galaxies, astronomers have begun to map the warm, hot intergalactic medium. And what they are finding is an atmosphere of staggering proportions. The circumgalactic medium extends outward for hundreds of thousands of light-years, perfectly mirroring the vast expansion of the dark matter halo. It is a cloud of superheated plasma that weighs hundreds of billions of solar masses. We have finally found the missing ledger entries. The missing baryons were never really missing. They were simply exhaled by the galaxy, pushed out into the vast, dark halo, hiding in plain sight as a million-degree fog that is too thin to touch and too faint to see. But how did half of our galaxy end up out there in the freezing void, heated to 1,000,000 degrees? The answer lies in the violent, breathing nature of the Milky Way itself. The galaxy is not a closed system. It operates like a colossal cosmic engine, constantly cycling matter in and out of its visible structure. When massive, short-lived stars reach the end of their brilliant lives, they do not simply fade away. They detonate in unimaginably powerful supernova explosions. These cataclysmic events release so much energy that they can briefly outshine the entire combined light of the galaxy. The shock waves from these explosions tear through the surrounding interstellar medium, acting like colossal snowplows, scooping up billions of tons of gas and dust and hurling it outward, away from the galactic plane. When thousands of these supernovae detonate in relatively close proximity over millions of years, they create something called a galactic wind. This is a hurricane of superheated plasma blowing perpendicular to the galactic disk, powerful enough to break the gravitational grip of the inner spiral arms and shoot matter hundreds of thousands of light-years out into the halo. The Milky Way is literally blowing bubbles of hot gas into the circumgalactic medium. Furthermore, we must remember the supermassive black hole at the center. While Sagittarius A star is relatively quiet today, it was likely an active galactic nucleus in the distant past. When a supermassive black hole actively feeds on surrounding gas, it does not swallow everything. A significant portion of the material is caught in the intense magnetic fields surrounding the event horizon and blasted outward in twin jets of relativistic plasma, shooting vertically out of the galaxy at nearly the speed of light. These ancient eruptions from the core also contributed to pushing the missing baryons out into the dark matter halo, heating the circumgalactic medium to its current blistering temperatures. So, the missing matter is the exhaust of the galaxy. It is the smoke lingering in the room long after the fireworks have detonated. But the story does not end with ejection. The circumgalactic medium is not a graveyard for lost atoms. It is a reservoir. It is a holding tank for the future. Over hundreds of millions of years, as this superheated plasma drifts far from the chaotic radiating disk of the galaxy. It slowly begins to cool. As it loses its thermal energy, the atoms slow down. They begin to feel the relentless inward pull of the dark matter halo once again. And so, a magnificent, slow-motion phenomenon occurs. The cooled gas begins to fall back down toward the galactic disk. It rains. The Milky Way experiences a constant, gentle, invisible precipitation of baryonic matter falling from the outer halo back into the spiral arms. This cosmic rain is what fuels the next generation of stars. The fresh influx of cooling hydrogen gas replenishes the molecular clouds, providing the raw material for gravity to compress and ignite new suns. The galaxy breathes out superheated plasma through the violence of supernovae, and it breathes in cool hydrogen through the gentle, persistent gravity of the dark matter halo. It is a galactic fountain, a continuous recycling ecosystem operating on a scale that dwarfs human comprehension. Think about the profound implications of this cycle. The atoms that make up your body, the carbon in your DNA, the iron in your blood, were forged in the heart of an ancient star that exploded billions of years ago. But those atoms did not necessarily travel straight from that dead star to our solar system. It is entirely possible that the very matter you are made of was once blasted completely out of the visible galaxy by a supernova wind. Your atoms may have spent hundreds of millions of years drifting in the million-degree fog of the circumgalactic medium, floating in the absolute silence of the deep halo, hundreds of thousands of light years away from the center of the Milky Way. You are constructed from material that has journeyed to the very edge of the abyss and fallen back like rain. There is a deep, resonant comfort in this continuous cycle of loss and return. Nothing in the universe is ever truly missing. It is merely transformed, relocated, and eventually recycled. The void is not stealing from us. It is holding our potential in a vast, invisible reserve. The dark matter halo is not just a cage, it is the atmospheric envelope that catches the exhaled breath of our galaxy and slowly returns it, ensuring that the spiral arms will continue to glow with the light of newborn stars for billions of years to come. As you lie in the quiet of your own room, consider the gentle rhythm of your own breathing. You are exhaling atoms into the air around you, atoms that will drift, circulate, and eventually be incorporated into something else. You are participating in a microscopic version of the great galactic fountain. The universe is not a static picture. It is a living, breathing process, and you are an inseparable part of its infinite recycling. If you find peace in the realization that your atoms have traveled the deep halo, and if you appreciate the quiet mysteries of the hidden universe, leave a soft, silent trace in the comments below. A gentle acknowledgement of our shared cosmic journey before you drift deeper into the tranquility of the night. The missing baryons have been found, hiding in the million-degree frost of the extended halo. We have balanced the ledger of the cosmos, but accounting for the physical matter only highlights a much deeper, far more terrifying absence. We have counted 400 billion stars. We have acknowledged the presence of billions of rogue planets. We have found the hot gas and the dark matter. The Milky Way is a crowded, heavy, overflowing metropolis of matter. Yet as we listen to the radio frequencies of the void, as we scan the atmospheres of distant exoplanets, we are met with an absolute, deafening silence. The physical matter is everywhere, but the voices are missing. We must now turn our minds to the eerie, crowded loneliness of a galaxy that is twice as large, but seemingly completely devoid of company. 400 billion. It is a number so vast that the human brain simply shuts down when trying to comprehend its true physical weight. We evolved to count the members of our tribe, to track the herd moving across the savanna, to measure the days between the phases of the moon. We did not evolve to conceptualize 400 billion of anything. If you were to sit in a perfectly quiet room and count out loud one number per second, without ever stopping to sleep, to eat, or to breathe, it would take you more than 12,000 years to reach 400 billion. That is longer than the entirety of recorded human civilization. Before the first stones of the pyramids were cut, before the first words of the oldest languages were spoken, you would have had to start counting, and you would only just be finishing right now. That is the number of individual blazing suns currently burning within the expanded borders of the Milky Way galaxy, and that is a conservative estimate. With the true scale of the dark matter halo and the outer disk finally coming into focus, the number could easily be much higher. We live in a crowded metropolis of light. The sheer density of stellar material in our local universe is staggering. For decades, we operated under the assumption that our galaxy was a relatively modest collection of perhaps 100 or 200 billion stars. Doubling the size of the galaxy does not just double the dark matter and the empty space. It doubles the glowing heart of the cosmos. It adds 200 billion new stories to the grand narrative of the Milky Way. Most of these newly counted stars are not like our sun. They are not brilliant, yellow-white spheres radiating intense heat and light. The vast, overwhelming majority of the stellar population consists of red dwarfs, known to astronomers as M-dwarfs. These are small, cool, incredibly dim stars, burning their hydrogen fuel so slowly, so efficiently, that a single red dwarf can live for trillions of years. They are the silent, unseen majority of the galaxy. They do not shine brightly enough to be seen with the naked eye from Earth, even if they are relatively close. But they are out there, filling the expanded volume of the outer halo and the deep disk with their faint crimson glow. And where there are stars, there are planets. This is perhaps the most profound paradigm shift in modern astronomy. Barely 30 years ago, we did not know if a single planet existed anywhere beyond our own solar system. We suspected they did, but we had no proof. The universe could have been a barren wasteland of lonely stars. But then we launched observatories like the Kepler Space Telescope, and we stared unblinking at a tiny, seemingly empty patch of the night sky, waiting to see if the light from any of those stars would dim just a fraction of a percent as a planet crossed in front of it. The results were nothing short of a revelation. Planets are not rare. They are the standard operating procedure of the universe. The laws of physics dictate that when a cloud of gas collapses to form a star, the leftover debris flattens into a swirling disk, and that disk inevitably coalesces into worlds. We now know, with absolute statistical certainty, that almost every single star in the night sky hosts at least one planet. Many of them host complex, sprawling solar systems with multiple worlds interacting in delicate gravitational ballets. If we take our new, doubled estimate of 400 billion stars and we apply the most conservative estimates of planetary formation, we are looking at a minimum of 500 billion planets in the Milky Way alone. 500 billion distinct physical worlds. There are gas giants far more massive than Jupiter, where hurricanes the size of Earth rage for centuries, raining droplets of liquid glass through crushing atmospheric pressure. There are rogue planets, as we discussed, drifting in the pitch-black void. There are carbon planets where the crust is made of solid diamond, and water worlds completely devoid of land, where a single globe-spanning ocean reaches depths of hundreds of miles, hiding bizarre, high-pressure forms of ice at the bottom of the abyss. But among this infinite diversity of worlds, there is a specific, highly coveted category that captures the imagination of every astronomer and every dreamer who has ever looked up at the dark. We are searching for the Goldilocks worlds. We are searching for the rocky planets that orbit their host stars at the exact, precise distance required for liquid water to pool on their surfaces. This is the habitable zone. If a planet is too close to its star, the oceans boil away, leaving a scorched, dead rock like Venus. If it is too far, the water freezes solid, turning the world into a sterile, icy tomb like Mars. But right in the middle, in that delicate, temperate band of orbital space, water can exist as a liquid. And wherever we find liquid water on Earth, in the deepest, darkest trenches of the ocean, in the boiling, acidic, hot springs of volcanic calderas, or deep beneath the miles of glacial ice in Antarctica, we find life. Biology is relentlessly stubborn, and liquid water is its universal solvent. When you double the size of the galaxy, you double the habitable real estate. Based on current data, astronomers estimate that perhaps 1 in 5 Sun-like stars hosts an Earth-sized planet in its habitable zone. Even if the ratio is far lower for the ubiquitous red dwarfs, we are still staring at a number that defies belief. There could be 20 billion, perhaps 40 billion, potentially habitable, Earth-sized planets spinning in the Milky Way right now. 40 billion worlds with sunsets and sunrises, with atmospheres and weather systems, with rocky shores and deep churning oceans of liquid water. 40 billion rolls of the cosmic dice. 40 billion laboratories where the exact same chemical processes that sparked the first dividing cells in Earth's primordial soup have had billions of years to operate. If life is a natural, inevitable consequence of complex chemistry under the right conditions, then the Milky Way should be teeming with biology. The galaxy should be a thriving, overflowing jungle of living ecosystems. And if biology is common, then the evolution of intelligence, while perhaps more rare, should still have occurred millions of times over the 13.8 billion-year history of the cosmos. By all logical reasoning, by every mathematical probability, the galaxy should be a crowded, noisy, vibrant metropolis. We should look out into the night sky and see the towering engineering projects of advanced civilizations. We should see the dimming of stars as colossal megastructures are built around them to harvest their energy. We should detect the chemical signatures of industrial pollution in the atmospheres of distant exoplanets. Most importantly, our radio telescopes, which have been sweeping the sky for decades, listening for the faint, unmistakable hum of artificial transmission, should be overwhelmed by a cacophony of alien broadcasts. But we see nothing. We hear nothing. The sky is perfectly, terrifyingly silent. This is the great, haunting contradiction of modern astrophysics. It is known as the Fermi paradox, named after the brilliant physicist Enrico Fermi, who, during a casual lunch conversation with his colleagues in the 1950s, famously looked up and asked, "Where is everybody?" It is a question that has only grown more urgent and more chilling as our understanding of the galaxy's true size has expanded. We have discovered that the universe provides an almost infinite number of stages, but the theater is completely empty. We have built the most sensitive instruments in human history, antennas capable of detecting the energy output of a single cell phone operating on a planet orbiting the nearest star, and we have pointed them at the dense, star-choked heart of the Milky Way, and we have found absolutely no trace of intelligence. There is only the static hiss of the cosmic microwave background, the rhythmic, mindless pulsing of spinning neutron stars, and the cold, dead silence of the void. How do we reconcile a galaxy of 400 billion stars and tens of billions of habitable worlds with the profound, unbroken silence we observe? The theories proposed to solve this paradox range from the deeply depressing to the profoundly isolating. The most prominent concept is the idea of the Great Filter. This theory suggests that there is a specific, nearly impossible evolutionary leap required for a species to evolve from simple, single-celled organisms to a spacefaring, radio-transmitting civilization. The filter is a wall, a barrier of probability that almost no one can climb over. The comforting version of this theory is that the Great Filter is behind us. Perhaps the sheer spark of life, the transition from dead chemistry to self-replicating biology, is an anomaly so incredibly rare that it has only happened once in the entire 4 trillion solar mass volume of our galaxy. Or perhaps the transition from simple bacterial life to complex multicellular organisms like plants and animals is the impossible hurdle. If the filter is behind us, it means we are a miracle. It means the Earth is the singular, infinitely precious jewel of the Milky Way, the only place where the universe has woken up to look at itself. In this scenario, the galaxy is silent because it is a pristine, untouched wilderness, and we are the very first sparks of consciousness in a vast, dark forest. The terrifying version of the theory is that the Great Filter is ahead of us. In this scenario, life is common, and intelligence is relatively inevitable. Thousands, perhaps millions of civilizations have risen on those billions of habitable worlds. They built cities, they composed music, they debated philosophy, and they eventually discovered the power of the atom and the mechanics of their own genetic code. but they never made it out into the stars. This theory posits that any civilization intelligent enough to harness the fundamental energies of the universe inevitably, predictably, uses that energy to destroy itself. They succumb to nuclear annihilation, to engineered biological plagues, to artificial intelligence slipping beyond their control, or to the slow, suffocating collapse of their own planetary biospheres. If the filter is ahead of us, then the silence of the galaxy is the silence of a graveyard. It means the Milky Way is littered with the dead, irradiated ruins of civilizations that reached for the stars and fell short, and we are simply waiting for our turn to hit the wall. But there is another dimension to this silence, a geographic reality of time and space that our brief, fleeting human minds struggle to process. The universe is incredibly old, and space is unfathomably vast. The Milky Way has existed for over 13 billion years. Human civilization, the period during which we have had agriculture, writing, and the ability to build, spans perhaps 10,000 years. We have only been transmitting radio waves into space for a little over a century. 100 years is an absolute microscopic fraction of a percent of the galaxy's history. It is a single grain of sand falling through an hourglass the size of a mountain. Imagine that advanced civilizations do arise, and they do manage to survive their technological adolescence. Even if a civilization lasts for 1,000,000 years, a staggering, almost inconceivable span of time for a species, it is still just a momentary flash in the dark. Now imagine these million-year flashes occurring randomly across a galaxy that is 200,000 light-years wide. A civilization could rise on the far side of the galactic disk, build a utopian empire, broadcast their accumulated wisdom into the void, and slowly fade away into extinction. Millions of years before the first primates even learned to walk upright on Earth. Their radio waves, traveling at the absolute speed limit of the universe, would pass through our solar system long before we even evolved ears to hear them, let alone antennas to catch them. We are like fireflies flashing our tiny, yet brief lights in a massive ancient forest. We flash, we burn bright for a fraction of a second, and we fade. And another firefly flashes on the opposite side of the forest 1,000 years later. We never see each other. We never overlap. The timing is wrong. The distances are simply too great. We are separated by deep space, but more importantly, we are isolated by deep time. There are darker theories, of course. Some suggest the galaxy is deliberately quiet. The dark forest theory, born from the realms of science fiction but debated seriously by astrophysicists, suggests that the universe is a highly competitive, dangerous place. In a galaxy with limited resources, any growing, expanding civilization is a potential threat to every other civilization. Therefore, the most logical, mathematically sound strategy for survival is absolute stealth. You do not broadcast your location. You do not send out friendly greetings. You stay quiet. You listen. And if you hear anyone foolish enough to reveal themselves, you eliminate them before they can become a threat to you. In this terrifying scenario, the sky is not empty. It is full of hunters, silently watching, holding their breath in the dark. The silence is not the absence of life. It is the presence of fear. It is the calculated, disciplined quiet of a predator waiting in the shadows. But tonight, as we lie here suspended in the calm, rhythmic rotation of our own tiny blue world, we do not need to dwell on the hunters. We do not need to fear the filter. We can choose to interpret the silence not as a threat, but as a profound, universal peace. Let go of the need for the universe to be loud, busy, and chaotic. Let go of the human desire to fill every empty space with noise and architecture. Think of the silence of the Milky Way as a comforting blanket, a galaxy of 400 billion stars stretching for hundreds of thousands of light years, entirely undisturbed. It is a place of monumental stillness. It is a quiet sanctuary. If there are others out there, perhaps they have simply evolved past the need to shout into the void. Perhaps they have turned inward, finding everything they need in the quiet contemplation of their own local space. Perhaps they are asleep. The loneliness we feel when we look up at the stars is a reflection of our own internal restlessness. We want someone to talk to because we are afraid of being alone with our own thoughts. But the galaxy is not afraid. It simply exists. It turns its massive, invisible wheels of dark matter. It cycles its superheated gas. It gives birth to stars, and it lets them die, all without making a single sound. It is engaged in a deep, eternal meditation. You are a part of that meditation. The atoms in your body, forged in those silent, ancient stars, are currently vibrating to the same fundamental frequency as the rest of the cosmos. You are an extension of the galaxy, sitting in a quiet room, experiencing the universe from one specific, fleeting perspective. The loneliness is an illusion. You cannot be isolated from a system that you are fundamentally woven into. You are the universe, experiencing the profound beauty of its own silence. Allow that silence to wash over you now. The static of the radio waves, the millions of uninhabited windswept worlds, the deep, dark gaps between the stars, they are not empty. They are full of peace. They are full of the quiet momentum of deep time. There is no urgency out there. There is no one demanding an answer. There is only the slow, majestic drift of gravity, pulling everything gently into its proper place. Let the overwhelming scale of the galaxy minimize the small, noisy anxieties of your waking life. They are nothing compared to the 400 billion silent guardians keeping watch in the dark. Close your eyes and join the great, quiet slumber of the Milky Way. Allow yourself to drift out into the dark matter halo, out past the speeding stars, out into the beautiful, unbroken silence of a crowded, sleeping universe. Stand at the edge of the Milky Way one last time. Look outward. Ask yourself the question that has driven this entire journey. Where does the galaxy actually end? Where does the home we have been mapping for the last hour cease to be home and become the alien, indifferent void? The answer, the final and most profound truth of this new cosmic perspective, is that the question itself is flawed. There is no edge. There is no wall. There is no line in the sand where the Milky Way stops and the rest of the universe begins. We have spent decades trying to draw a circle around our existence, trying to define a neatly contained volume of space that we can label and understand. But the universe does not respect our need for boundaries. It does not recognize the lines we draw on our star charts. The reality of the cosmos is one of continuous, unbroken connection. Think of the atmosphere of the Earth. We are taught in school that space begins at the Kármán line, roughly 60 miles above sea level. It is a useful legal definition for astronauts and engineers, but nature does not care about the Kármán line. The atmosphere does not simply hit a wall and vanish. It thins out. It graduates from the thick, breathable air at the surface to the thin, freezing stratosphere, and then to the tenuous exosphere where individual atoms of oxygen and nitrogen drift miles apart from one another. Even thousands of miles out in space, far beyond the orbit of the International Space Station, there are still traces of Earth's atmosphere. There is a geocorona, a cloud of hydrogen atoms surrounding our planet that extends past the orbit of the Moon. The Earth does not end, it fades. It gradually dissolves into the solar wind. The Milky Way behaves in exactly the same way, but on a scale that defies comprehension. The density of stars drops as you move outward from the core, but it never truly hits zero. We have the dense city center of the galactic bulge. We have the suburban sprawl of the spiral arms where the sun lives. We have the rural, scattered population of the stellar halo. And beyond that, in the deep dark, we have the drifters. We have solitary stars, ejected from the galaxy billions of years ago, floating in the immense emptiness hundreds of thousands of light years from the center. Are they part of the Milky Way? They were born here. They carry our chemical signature. They are loosely bound to our gravity. But they are alone in the night. The boundary is not a line. It is a gradient of loneliness. And the dark matter halo, the invisible structure that gives the galaxy its true mass, follows the same pattern. It is densest in the center, and it tapers off gently, smoothly, invisibly into the cosmic background. There is no point where you can say, here is the dark matter of the Milky Way, and there is the dark matter of the universe. They are the same substance. They are part of the same continuous fabric. The halo of our galaxy merges seamlessly with the filaments of the cosmic web, the massive skeletons of dark matter that connect all galaxies together. We are not an island in an ocean. We are a knot in a vast three-dimensional net. This realization dissolves the very concept of isolation. If there are no borders, then we are connected to everything. The gravity that holds you to your chair is the same gravity that binds the moon to the earth to the sun to the galaxy, and the galaxy to the Virgo supercluster. It is a single, uninterrupted field stretching across the entire observable universe. When the Milky Way moves, it drags the local space-time with it. When Andromeda moves, we feel the tug. When the great attractor pulls, we slide toward it. We are not separate entities floating in a vacuum. We are distinct notes in a single, continuous frequency of matter and energy. The light tells the same story. A photon of light leaving a star in the Milky Way travels forever. It crosses the galaxy, exits the halo, and sails out into the intergalactic void. It will travel for billions of years. It might eventually strike the retina of an observer in a distant galaxy. Or it might travel until the end of time, stretching and cooling as the universe expands, but it never stops existing. The influence of the Milky Way is technically infinite. Every star that has ever shone in our galaxy has sent a sphere of information expanding outward at the speed of light. We are announcing our presence to the universe, constantly, eternally. We are touching every corner of the cosmos with our light. So, the size of the Milky Way, whether it is 100,000 light years, 200,000, or a million, is just a human attempt to categorize the infinite. It is a label we use to make ourselves feel comfortable. But the universe is not asking us to measure it. It is asking us to experience it. As we reach the end of this journey, I want you to let go of the numbers. Let go of the need to know exactly how wide the galaxy is. Let go of the fear of the collision with Andromeda. Let go of the anxiety about the missing matter or the silent aliens. Instead, focus on the feeling of the structure itself. Visualize the Milky Way not as a map, but as a living organism. It breathes. It inhales cold gas from the intergalactic medium, pulling it down along the spiral arms to feed the birth of new stars. It exhales hot plasma through supernova explosions, enriching the halo with the elements of life. It grows. It consumes smaller galaxies, absorbing their history and their energy into its own. It moves. It spins with a majestic, slow grace, taking 250 million years to complete a single rotation. It is ancient, scarred, violent, and beautiful, and you are inside it. You are not an observer looking at a picture. You are a component of the system. The atoms in your body are galactic matter, temporarily assembled into a form that can think and feel. You are the Milky Way becoming conscious of itself. You are the galaxy looking in the mirror. The expansion of our understanding, the realization that we are bigger, heavier, and more complex, is a mirror of our own internal growth. We used to think we were the center of the universe. Then we realized we were orbiting the sun. Then we realized the sun was just one of billions. Now we realize the galaxy itself is a blurred, boundless thing, merging with its neighbors in the dark. Every time we learn more, we become smaller, but we also become more connected. We lose our dominance, but we gain a family. We lose our borders, but we gain the infinite. There is a profound peace in surrendering to that vastness. The anxieties of your daily life, the deadlines, the conflicts, the noise of the human world, they are all happening on a microscopic grain of dust, suspended in a sunbeam, orbiting a star that is just one of 400 billion, inside a structure that has no end. In the face of that scale, your problems do not vanish, but they find their proper perspective. They are small. They are temporary. They are manageable. The galaxy is large enough to hold all of it. It is large enough to absorb your worry and replace it with wonder. It is large enough to take your fear of the dark and turn it into a comfort. Because the dark is not empty. It is the heavy, protective blanket of the halo, holding us together, keeping us safe, binding us to the rest of the cosmos. Now, as the image of the spiral arms begins to fade from your mind, allow yourself to drift. Imagine you are one of those solitary stars at the very edge of the halo. You have traveled for billions of years to get here. You are far from the noise of the core. You are far from the chaos of the collision. You are floating in the perfect stillness of the deep void. The gravity here is gentle. The light is soft. The silence is absolute. You are no longer bound by the need to move fast. You are no longer fighting the escape velocity. You are simply hovering, balanced, weightless, drifting. The boundary between you and the universe is dissolving. The line between your consciousness and the sleep you need is fading, just like the edge of the galaxy fades into the night. There is no wall you have to climb over to fall asleep. There is no border you have to cross. You just have to let go. You just have to let the gravity of the dream pull you in, drift into the red, ancient glow of the halo stars. Drift into the invisible embrace of the dark matter. Drift into the silence that has been waiting for you for 13 billion years. The galaxy is your home, and your home is vast and quiet and safe. The universe is sleeping now. The stars are burning their quiet fuel. The streams are flowing in their silent rivers, and you are drifting with them. If this journey into the expanded dark has brought you a measure of peace, if it has helped you find your place in this limitless structure, leave a signal in the darkness below. A simple comment, a thought, a trace of your presence to let us know that you were here, watching the universe unfold. Subscribe to the frequency of this channel so we can guide you back into the cosmos when the noise of the world becomes too loud again. But for now, there is nothing left to measure, nothing left to count, nothing left to fear. There is only the drift. Good night, traveler. The galaxy is watching over you.